In this section, I'll show you how to solve equations of quadratic form using another method. Let's take a look at an example. Solve the following equation. Here on this left side we have a quadratic expression equaling 20. The last method we used was the intersection method, when we would plug this into y1 and that would create a parabola opening up. Since that's positive, plug that into y2, that would create a horizontal line at 20, and then find out where they intersect and use the input coordinate of the intersection points as answers. In this section I'm going to show you how to use a formula, what we call an algebraic method, and it's something called the quadratic formula. The quadratic formula says the following: if you have an equation in this form, if ax squared plus bx plus c equals 0, where a, b, and c are real numbers, then the x value that solves this equation will equal this value here, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the idea is that the answers to this equation, if it's in this form, can be found by this, what I call conglomeration of the a, b, and c values. If we were going to apply this to this equation here, we'd have to first put this into this form, where 0 is on one side and everything else is on the other. So here's what that looks like. Let's do it. We're going to need to subtract 20 from both sides, so we get 0 here and then everything else on the other. So here's what that looks like. We're going to subtract 20 from both sides, and so we'd get 0 on the right and this piece on the left. So now this is in this form, so now we can apply the formula. So the x values that solve this equation we're going to find by using this. So here our b is negative 4, our a is 1.5, and our c is negative 10. So we should write that down to help us as we insert these values in here. So here's what inserting those values looks like into the formula. So our x values that solve will look something like that. Notice how I have parentheses around the b value, so that's the negative b, and then b appears here, so I put parentheses here, and I use parentheses anywhere I insert a value. That's going to help you. So we can use our calculator to solve this and recognize there's two. That's a plus and a minus. So let's take them one at a time. Before I show you that, let me show you how to get a single value under there. So let's go to our calculator, and I'm going to insert these values here just on a home screen as is. So negative 4 squared minus 4 times 1.5 times a negative 10. So that's 76. So what we have here is a value of 76 underneath the square root. That's a negative of a negative 4, so that's positive. And then on the bottom we get 2 times 1.5, or 3. So this is a good way to calculate this value. And now we can use our calculator to find the value for these two values. Remember, it's plus and minus. So let's go over here and do this. You need parentheses around the entire top. So 4 plus the square root of 76. Got to close the parenthesis twice, divided by a 3. So 4.2 approximately is one answer. So 4.2. The other is the subtraction. So 4 minus those two. And let me just get these out of the way here. So we have two values here. We have 4 plus square root of 76 over 3, or 4 minus the square root of 76 over 3. So we did one of them. Let's go do the other one. I'm going to use my entry feature. I hit second enter. Second enter helps me manipulate previous entries. So I'm going to change that to subtraction, hit enter, and negative 1.6 we'll call it. Negative 1.6. So two answers here, 4.2 and negative 1.6, satisfy this original equation here. And you can verify using the graphical method or intersection method by putting this again into y1, that into y2, find out the points of intersection, and you'll see that those first coordinates are these values here.